In this video, we'll look at describing vectors in terms of their components. Before we get onto what we mean by components, let's talk about multiplying a vector by a scalar. So it is possible to multiply a two-dimensional line vector by a scalar, i.e. a number. When we do this, we change the magnitude or length of the vector by whatever factor we multiply by. If we multiply by a negative number, we reverse the direction of the vector, but otherwise the direction doesn't change. Let's look at an example. Let's take this vector, a. We could, for instance, times a by 2, and we'd obtain this vector, 2a. It has the same direction as a, but twice the magnitude. Or what about minus half a? That would look like this. Its magnitude is half a's magnitude, and it has the opposite direction to a, since we multiplied by a negative number. So you see, multiplying a vector by a number scales the vector by that factor, hence why we call numbers scalars when discussing vectors. Now let's introduce two very important vectors, I and j. These are very common vectors, and these labels for them, I and j, are quite standard. We call these vectors orthogonal unit vectors. Orthogonal just means they're at right angles to each other, and unit means they have length 1, as you can see in the diagram. Another thing to note is that I has the same direction as the x-axis, and j has the same direction as the y-axis. The reason these vectors are important is that we can use them to express any vector in the plane. Let's see an example. Say we have this vector, AB. Well, using the rules for adding vectors that we discussed in the previous video, this vector is I plus j, which is just 2i plus 2j. Let's take this vector now, CD. This is I plus a half I plus 3/4 j. This simplifies to 5/2i plus 3/4j, or in decimal form, 2.5i plus 0.75j. In fact, we only need to determine the horizontal and vertical length of the vector to figure out how to express it in terms of I and j, without actually bothering to draw out multiple copies of I and j every time. If our vector is in the standard position, that is, it starts at the origin, we can easily use the axes to find these lengths. So let's take this vector, OP. Its horizontal length is 3, and its vertical length is 2 3/4, or 2.75. So, since I and j each have length 1, we can write OP as 3i plus 11/4j, or 3i plus 2.75j in decimal form. Now, let's look at these expressions in more detail. The first thing to note is that when we express a vector in this form, the coefficients of I and j, i.e. the numbers multiplying I and j, are called the components of the vector. So, these are the components of AB, for example, 2 and 2. Another thing is that when vectors are expressed like this, addition is quite straightforward. Let's try adding AB to CD. Well, that would be 2i plus 2j, that's AB, plus 2.5i plus 0.75j, that's CD. Just like in any other algebraic sum, we gather up and combine the like terms, so we end up with 4.5i plus 2.75j. Finally, let's introduce a new, very common way of denoting two-dimensional line vectors. Vectors expressed in this new way are called column vectors. To write a given vector as a column vector, you simply write its two components as a column enclosed in brackets. So, the vector AB would be written like this. The vector CD, on the other hand, would be written like this. These are column vectors. Any line vector can be written as a column vector, you just need to know its components, which, as we've seen, are simply its vertical and horizontal lengths. One quick final point. Note that we always put the horizontal I component in the top of the column vector, and we put the vertical j component in the bottom. So that concludes this video on components of vectors.
And she saw that swirl of yellow light between the mountains and the stars. There was such music in it.